Welcome, children, to another session of maths. Today we are going to look at the sine formula and the cosine formula and how we can use that to calculate sides and angles of a triangle. Okay, let's get right into it. The sine formula. Last session we spoke about the area of a triangle, and if you remember, we expressed it in three different ways: half AB sine C. And we can do the same for each side of the triangle. All right? So if I have a triangle ABC, if I know the sides and I know the angles, I can write the area formula in three different ways. So there's a very neat little trick. If I divide right through by half ABC, I end up with an equation that looks like this. Sine A over A is equal to sine of B over B is equal to sine of C over C. So the opposite side over the angle. Opposite side over the angle. And that gives me the sine rule, okay? Or if I flip them all around, because they are equal, A over sine A, B over sine B, C over sine C. That is known as the sine rule, okay? What does it tell us? Mathematically, for any triangle, the length of the sides are directly proportional to the sine ratios. So the length of the side is proportional to the sine of the angle. So sine A over A, sine B over B, okay? Those are proportional. And remember, we said proportional means two ratios are equal. That is what we are talking about. All right, let's look at some problems very quickly. For any triangle, we know the value of two angles. We can find the remaining one by using the property sum of a triangle, that we know. If we know the length of one side, we can use the sine rule to find the length of the other sides. Okay, so let's have a look at this. If I have a triangle ABC, solve the triangle and three significant figures if necessary. They say solve the triangle. Now, when they say solve the triangle, that sounds a bit strange. What it means is this. You must find the measures of all the unknown sides in that triangle. So, if I have a triangle ABC, and if I quickly draw that again, triangle ABC, and let's fill in the values. So, A is 40 degrees, B is 80 degrees, 40 and 80 is 120, so C must be 60 degrees. That's by angle sums of a triangle. And then C. C lies opposite angle C. So this is C. C is equal to 10. This across here is B, and that across there is A. So what am I supposed to do when they say solve the triangle? I must find all the bits of information that is missing. I must find B, A, and I must find C, which I've already done. Okay? So those are the things when we are trying to solve the triangle. So first of all, there is angle C. By the sine formula, A over sine A, C over sine A. So if I'm looking at A and C, there is C's 10, that's 60, 40, so I can find what A is, and that is what we find A to be. All right. In the similar way, I can find out what B is. So B over sine B is C over sine C, and I solve for that. And very straightforward, my answer comes out there as well. What you need to pay attention to here as well, three significant figures. Three significant figures. Notice, in this case, three significant figures is 2 decimal places. In this case, it is 1 decimal place. So don't confuse significant figures and decimal places. All right, let's look at the cosine formula. Right? If we have an example like this, and we want to find out the side here, the sine rule will not help us. In this case, we have no angles, so we cannot use the sine rule. So how do we solve angles and sides if we are missing information? So we have another rule which is called the cosine rule. Now, this is not required in our testing for exam purposes. But very quickly, there is an example of how we derive the cosine rule. So if I drop a altitude, which means a perpendicular, and I call the one side x, I can then write in terms of Pythagoras h squared. And then if I look at the other triangle, I can write h squared again. Making those two equations equal, I then get this equation. Now, I can write x in terms of trig, b cos a. And if I substitute that in there, I have a squared equals b squared plus c squared minus 2bc cos a. Now, that's a very interesting formula. We'll come back and look at it. Here, if we have an obtuse triangle, we have the same story. We can write it in terms of h using Pythagoras. So we have two triangles for Pythagoras, CPA and CPB. And we can write that also in terms of h, making them equal. Okay? And then writing x in terms of the angle, trig ratio, I can substitute that into the equation, and you will see, sorry, I went a bit quickly there, you will see that I come to the same answer. A squared equals b squared plus c squared minus 2bc cos a. That looks like quite a mouthful and quite a bit of stuff in there, but we can actually simplify that. When we look at the triangle, and if you label your triangles, your angles and your sides should always be labeled opposite each other. So if I have angle A, the opposite side is angle with side A. So if I'm doing that, then I can say a squared. If I'm looking for angle A, then the thing I am solving for is A. So it'll be a squared equals b squared plus c squared. If I'm looking at angle B, then the thing I'm looking for is b squared. So I can write this in different ways as well. So b squared can be written in terms of a squared, and c squared can be written that. So we have three equations here that we can call the cosine rule. And you can see the pattern. A squared is b squared plus c squared minus 2bc cos of a. If it's b squared, you minus 2ac cos of b. So you can pick up the pattern of how we write the rule. Okay? That is known as the cosine rule. What is important about it? We can write the angles and sides if we are given three sides and an angle. So if we are missing any one of them, we can find it. Okay, so let's have a look at an example. A is 90 degrees. If A is 90 degrees, see what happens. Cos of A, cos of 90 is 0, so that term goes away. So if A is 90 degrees, the equation comes down to a squared equals b squared plus c squared, which is what? Pythagoras. So a special case comes out from the cosine rule. So from the cosine rule, I can show that a triangle obeys Pythagoras' formula. That's kind of very neat, I think. Okay, that's for mathematicians that get excited, I think, with these things. Right, let's consider the formula. We can write the formula in terms of the angle. So if I want to find the angle, cos A, I can write it in terms of the sides. So there we go. If I have a triangle and I have all three sides, but I don't have the angle, I can use the cosine formula to find out the angles. That's very neat. All right? And we can do the same for B and C. And again, you can see the pattern. If it's cos A, it's b squared plus c squared minus a squared. If it's cos B, a squared plus c squared minus b squared. So you minus whatever the angle letter is, and it's over the other two sides. All right, so you can assimilate those formulas in your own time, but let's go ahead and look at a few examples. All right, in this case here, there's a figure, ABCD, cyclic quadrilateral. What does cyclic mean? Cyclic means that this quadrilateral can be drawn with a circle going through all 4 points. So that is an important part of that question. Normally when we read this, we sort of read through quickly and we see quadrilateral, but it is cyclic quadrilateral. So if we look at this, they want us to find BCD, BCD, we need to find that angle, and we need to find the length of BD. So BCD I can find using this fact, which is cyclic. So that plus C must be 180 degrees, so very easy to find BCD. Great. Now, if I'm going to look at BD, I have this angle, I have two sides. Included angle and two sides, I can use the cosine formula to find BD. So that squared plus that squared minus 2BC times that angle, cos of 86 degrees, and that is squared. So the square root of that will give me the length of BD. Now again, 3 significant figures. So if I look at that answer, I need to round it up to 3 significant figures, 13.1. So be very careful again here, 3 significant figures. When we are doing those calculations, carry more decimal places than you need. Always carry more decimal places, so when you round up your answer at the end, your answer is more accurate. All right, let's have a look at another example. Here we have ABC, we're given 3 sides, find the angle, hence find the area. So if I've got 3 sides and I've got the cosine rule, I can find the angle using the formula. Okay, now when we get to that step, we will have to use our calculators and find the inverse cos function to get the angle. All right, and normally we ask angles to be written to 1 decimal place, not significant figures, to 1 decimal place. All right, and once we have that, we can find out the area, which is half AB sine C. So you can see that we can use the sine rule, the cosine rule, and the area formula to find any property of a triangle, whether it's a side or an angle. Okay, so I hope all those things round up for you, all the things we have done so far on triangles, in terms of area, in terms of similar triangles, and now in terms of the sine rule and cosine rule. Thank you very much.